I think the people that will watch this video are my mom, my grandmother, and my aunts.
Hello and welcome. I'm Hannelore de Mulder. We are at the machine room in KU Leuven. I'm here with Dr. Brecht Reynders, a postdoc at Network Systems Telemic. Hello, Brecht.
Hello, Hannelore. Just Brecht is fine.
Yeah? Okay. Can you tell me what is your PhD topic?
So, I graduated this year in May, and my PhD topic was about low-power wide area networks, or LP1 short. And I did a system analysis and performance measurements in simulation for low-power wide area networks in dense scenarios.
And you talk about LP1. Can you explain me what it is?
So, low-power wide area networks are networks that use very low power to transmit data, but over very long distances. So low power, that means like a few milliwatts of power. Compare this to your phone, which uses 2 watts. So it is a lot of reduction of power. They do this by exchanging bandwidth or data rate by distance. So by lowering the throughput, you gain basically distance. That is what it is. That is basically low power wide area.
And why should people use it?
Well, people should use it. They don't have to use it, but it's very handy for when you have to do measurements on a remote location. For example, think about tracking trucks. So you just put a sensor there, you add the GPS module, and then basically every hour you transmit the location of the truck, and then you can follow the truck throughout the country, for example. Because it's long range, it's very easy to do that. But maybe closer to the house, you can monitor your own garden, for example, measure the moisture, and then you can know when you have to water the plants. Very useful for these dry summers in Belgium. Or you can put a meteo station outside, and then you can measure the solar activity, you can measure rain, the temperature, and you can send all that information inside, and then you can see inside whether you have to wear a sweater outside, whether you have to bring your raincoat, stuff like this.
So this sounds a bit like Bluetooth. Is it Bluetooth?
Well, it's definitely not Bluetooth. If it was Bluetooth, then we didn't call it low power wide area networks, but it looks a bit like Bluetooth in the sense that we also have sensors that send regular data, or send data at regular intervals. So in Bluetooth, data is typically sent every few seconds. For example, your heart rate is sent every few seconds to your smartphone or your step count or whatever. Similarly, in low power wide area networks, sensors, for whatever reason, send data every X amount of hours then, or X amount of minutes to the internet. So in that sense, it's a bit similar. Of course, the distance and the throughput are completely different. Bluetooth uses way higher throughput, so you can send more data. Low power wide area networks, on the other hand, send less data, but they can send over longer distance.
And is there a possibility that it's interfering with the Wi-Fi at my house?
Well, if you have a LoRa device or a low power wide area network device in your house and your Wi-Fi is very bad, the probability of it being your neighbors is way higher than that sensor. So the sensor is already sending very little amount of time, which makes that the interference will not be that bad. 2, they're working on a different frequency, so they should not hear each other. It's like bats and humans. We cannot hear the bats, they don't hear us, so we're using different frequencies to communicate. Also, now that we're on the topic, low power wide area networks, they transmit on the 433 megahertz or the 868 megahertz band. They are lower frequency, they have a larger wavelength, so that is actually better for propagation. So in that sense, they also gain to use the lower frequencies. And your Wi-Fi at home is either 2.4 or 5. That means way higher, so it's shorter range. But that is also why they don't interfere with each other.
So you can't read my data then?
Well, I can read your data if I would want to everywhere. It's long range, so I can even intercept it at long distances. But usually you use keys to secure your data. In LoRaWAN and in Sigfox, I know that there is keys already in the protocol. So usually I should not be able to read your data. Of course, if you decide not to use it, I probably can read your data, yes.
And you say low range. Does it mean that it has high power and is very bad for my health?
Very subjective question, I think. First off, it is already low power, so it does not send with a lot of power. That means it is below 10 milliwatts, which is significantly less than what your smartphone is broadcasting. Also, the devices that you're using, usually you're not holding them against your head like you do with your smartphone.
Mm-hmm.
So in that case, I think low power wide area networks are not really a risk for your health if you compare them to the typical cellular system. So I wouldn't worry about those technologies.
And how much does this cost?
Well, the sensors themselves are quite cheap, ranging from 5 to 15, 20 euros for a module with an MCU on it. Of course, beside the sensor itself, you also need a gateway. So either you use a gateway system structure that is already there, like Proximus, and then you pay per month, or you use the Things network, which is a free service. And then you can basically only buy a sensor, and then it's just 13 euros. If you don't have service at your place, then you probably also need a gateway. The gateways are more expensive, around 200-300 euros. So, well, for 200 euros, you have a full working system, I would say. So if you compare it to your Wi-Fi system, it's more expensive.
Yeah.
But of course, they work bidirectional, so you can make your own gateway with a small sensor, make your proprietary protocol, and then it's like 50 euros, which is then again in the range of your Wi-Fi. So I would say it's very cheap.
Mm-hmm. Why do you think this conversation in English? Because you work at KU Leuven. Isn't it a Flemish university?
Am I right?
Then I asked to make Dutch their default language rather than English.
I asked exactly the same question in like that channel. Yeah, so we have a Slack channel, which you're aware of. Yeah. Because you're in the Slack channel.
Yeah. I sometimes respond.
So I was right in there, and then I said, why don't we do this in Dutch? Because, well, we're a Dutch university. People watching this video will maybe be Dutch. Mm-hmm. Also, my grandmother might be watching. Yeah. I think the people that will watch this video are my mom, my grandmother, and my aunts.
True.
So therefore, I thought it was a better idea to make it in Dutch. Yeah, I think. But I think it's because I did my PhD presentation in Dutch. People were a bit angry that they didn't understand whatever I did. So therefore, they wanted to have an English explanation as well.
Who were angry?
I don't know.
The people behind the camera. Are we still recording? Okay. All this was your PhD topic. What are you researching now?
Fair question. Now I am more working towards putting intelligence on the sensor itself. So you have, actually it's completely different. It's more about spectrum scanning and cognitive radio. So you have spectrum, for example, the 868 megahertz band, where all the low power wide area networks are located. And you want to access the channel and on a time slot and a frequency slot that is not occupied. So you want to do the scanning and all that stuff very fast on your sensor. So at this moment, I am working to make all the intelligence to do that on the sensor itself. So on very low cost hardware. That is what I'm doing now. Mm-hmm. And this in the hope to someday start my own company.
Yeah. And do you think that there is an effect on the society? And what is this effect?
For low power wide area networks, I think what we did for society is actually that we popped the bubble. When I started my PhD, there was a big hype on low power wide area networks. The companies providing the low power wide area networks at that time were promising the most ridiculous things, that they were going to connect millions, billions of devices in very small areas. And I think we definitely popped that bubble and showed what actually these protocols can do. And then, well, basically stop wasting the ridiculous amount of money they spent on making unnecessary claims.
That sounds good. Thank you very much for all your information. Thank you guys for watching. See you next time. Bye.
The end.
Would you like to do it in Dutch again?
What, my presentation? Or
This.
I can do this in Dutch again.
The battery died.
Oh, the battery
Oh,
died.
no.